Good morning, my virtual learners. Welcome to another fun-filled learning of Valenzuela Live in Mathematics 7. This time, quarter 3, week 7. Let me remind you that you need to have with you your learning packets, notebook or paper and pen, which you'll need for jotting down important notes. You may share your answers to the questions later by keying your answers in the comment box or by hitting the reaction buttons. Lastly, it's a fun for learning mathematics. Are you ready? Let us begin. Okay, the lesson for today's live streaming is all about circle and its related terms. At the end of this live session, you, as a learner, should be able to learn on how to illustrate a circle and the terms related to it. We've learned a lot about in geometry so far, and there's one really important geometric shape that we still need to cover, and that shape is circle. Circle is a closed curved figure, all points of which are equidistant from a fixed point called center. Since the invention of wheels, circles had been extremely important on all humanity. In fact, you probably see circles almost everywhere you try. Here are some objects that may represent a circle. The first one is the hula hoops, followed by a wedding ring, and the last one is a basketball ring. Again, here are some representations of circles in our real life situation. Mathematically, again, circle is closed curved figure, all points of which are equidistant from a fixed point called center. And then the best way to understand what that means is to see that in action. So here's a single point to start. And now let's start drawing points that are equidistant from it. This point is a foot away to the right. And let's make another point a foot away, but in another direction. Let's say it's up here. Now, let us make another one, also a foot away, but in another direction. And let's make another, and another point, another point, and another point, and another point, also a foot away. Now, by the use of a drawing compass, let us connect all the points and, okay, again, connecting all the points using a drawing compass and, whoo, you see what's happening? Joining the points equidistant from a fixed point, we're able to form or construct a circle. But of course, we usually don't see this as a set of points because there's infinitely many of them. So they form a continuous circle. How to name a circle? In naming a circle, circle is named by its center. The circle on my right is called circle O. In symbols, is 1. Since its center is at point O. The center, or again the point O, is also an example of an interior point because it lies in the interior of the circle. Point B lies on the circle. Therefore, it is classified as a point on the circle. The point outside is called the exterior point, point C. Terms related to the circle. The first term related to the circle is a radius. A radius is a segment whose endpoints are the center or any point on the circle. In the circle to my right, line segment OJ is called the radius. Again, line segment OJ is called the radius. It is a line segment from the center to any point on the circle. We can conclude that all radii of a circle are equal in measure, just like this. 1, 2, 3, 4, and 5. Again, all radii of a circle are equal in measure. The second term related to the circle is called a chord. A chord is a segment whose endpoints are any 2 points on the circle. Segment AB is an example of a chord since it's joined 2 points, A and B, on the circle. The third term related to the circle is a diameter. A diameter is a chord which passes through the center of a circle. It is twice the length of a radius. Again, I would like to emphasize it is twice the length of a radius. Chord or line segment MN, which passes through the center of the circle, is known as the diameter. The diameter again is twice the length of the radius of the circle. It is also the longest chord of this circle since it passes through the center. We can conclude that the diameter of the same circle are equal in measure. Again, the diameters of the same circle are equal in measure. The fourth term related to the circle is a secant. A secant is a line that contains a chord. Based upon on the circle, line JT is an example of a secant because it is a line that intersects a circle at 2 points. Take note, a secant is technically not a chord, but it contains a chord. The fifth term related to the circle is a tangent. Tangent is a line that intersects the circle at exactly 1 point. This point is called the point of tangency. Based upon again on the circle, line XY, again line XY is tangent to circle O. Again, line XY is tangent to circle O at point E. Point E is the point of tangency. Again, let's try to look back to the different terms related to the circle. First one is the point O. This is the center of our circle, followed by the radius, followed by the chord, the diameter, the secant, and the tangent. Now, it's your turn to identify the different terms related to the circles. Try this. Hit the reaction button below. Identify line ST. Hit like if it is a secant. Hit heart if it is a chord. Hit haha if it is an example of radius. 5 seconds. Time is up. The correct answer is like button. Line ST is an example of secant. Try this. Identify O. or point O. Hit like if it is an example of radius. Hit heart if it is an example of a center. Hit haha if it is an example of a chord. 5 seconds. Time is up. The correct answer is heart button. Next, line segment PR. Hit like if it is an example of radius. Hit heart if it is an example of secant. And hit haha if it is an example of a chord. 5 seconds. Time is up. The correct answer is haha. It is an example of a chord. Next one, line segment OM. Like if it is a radius. Heart if it is a secant. And haha if it is an example of diameter. 5 seconds. Time is up. The correct answer is like. It is an example of radius. Last one. Line segment SN. SN is an example of a radius. It is an example of a secant. Or it is an example of diameter. 5 seconds. Time is up. The correct answer is it is an example of diameter. Other basic terms needed in the study of circles are defined first by their central angle. Central angle is an angle formed by two radii of a circle whose vertex is the center of the circle. Angle AOB is an example of a central angle at circle O. Again, angle AOB is an example of central angle at circle O. On the other hand, inscribed angle are an angle whose vertex lies on the circle, whose sides are chord of the circle. Angle ACD is an example of an inscribed angle. As what we observe, the sides of an angle ACD is a combination of two chords, line AC and line DC. Again, combination of two chords, line AC and line DC. We also have an arc. An arc is a portion of a circle. It is formed by 2 points and a part of a circle between them. The 2 points are known as the end point of the arc. Arcs of a circle have 3 types. Let us discuss first the semicircle. Semicircle is, it is the half the circle. It is half the circle and the endpoints are points of the diameter. Arc CAB, arc CDB are examples of semicircles. Again, arc CAB and arc CDB are examples of semicircles. After semicircle, we also have minor arc. Minor arc or an arc smaller than semicircle. Arc CA and arc AB, arc BD, arc CD, arc AD are example of minor arcs. Again, arc CA, arc AB, arc BD, arc CD, and arc AD are example of minor arcs. To name a minor arcs, usually we use two letters. After semicircle and minor arc, lastly we have the major arc. Major arc is an arc greater than a semicircle. The major arcs here on our example are arc CAD, arc CBD, arc ACD, arc ACB, arc BAD. Again, the examples are arc CAD, CBD, ACD, ACB, and BAD. To name a major arc, we usually use three letters. Now, it's your turn to identify different types of arcs. Try this. Again, hit the reaction button below. Let us identify first the arc STN. STN. It is an example of semicircle or a minor arc or a major arc. 5 seconds. Time is up. The answer is right. It is an example of STN. Good job. Next one. PR. Arc PR. Semicircle, minor arc, or a major arc. 5 seconds. Time is up. Arc PR is an example of arc, minor arc. Next one. How about the arc TSM? It is an example of semicircle, minor arc, or a major arc. 5 seconds. Time is up. Arc TSM is an example of semicircle. Another one, arc SMP. 5 seconds. Arc SMP is an example of major arc. Good job. And then the last one, arc SP. Arc SP is an example of semicircle, minor arc, or major arc. 5 seconds. The answer is arc. It is an example of a minor arc. At this turn, I want you to name each of the following by referring to the circle P. Okay, can try this. Let us name a circle. It is circle P. Or in symbol, this one, circle P. Next, radii. The radii is line segment PO. It can be PR, PM, PA. Next one, the diameters. It can be line segment OM, line segment AR, line segment OM, and AR. Next one, tangents. It can be line SN and line TL. Chord, line segment OM and line segment ER. It can be also line segment MR. Secant, line MR only. Point of tangency. The point of tangency are at point O and point M. The central angles. We have angle APO, angle OPR, angle RPM, angle MPA. Next is the major arcs. The major arcs are arc AOM, OMA, RAO, MAR. If we have major arcs, we have minor arcs. Arc AO, OR, RM, MA. Activity time. Answer what's more, exercises A and B. For what's more, exercises A, identify the following parts of the circle below. These are the questions. For exercise B, write T if the given statement is true. If not, change the underlined word or phrase to make the statement true. For quotes for the day, circles like the soul are never ending and turn round and round without a stop. Again, circles like the soul are never ending and turn around and round without a stop. And that's the end of our live streaming session for today. I am Marcel Mameta of Bapulan Lupa National High School. Good day